Dear students, welcome to this video. Today we'll be discussing here some more problems on differentiation by trigonometrical transformations. In the previous video we have already done some problems. Let us see some more problems today. So let us start with this question. If y is equal to tan inverse root over 1 plus x square minus 1 upon x, then find derivative of y with respect to x. Here we will put x is equal to tan theta. So we are getting here y is equal to tan inverse root over 1 plus tan square theta minus 1 by tan theta. This becomes tan inverse sec theta minus 1 upon tan theta. Now we'll simplify it. We'll reduce it in the form of sin theta and cos theta. So we will get this is equal to tan inverse 1 minus cos theta upon cos theta and sin theta upon cos theta. This cos theta will be cancelled out. So this is equal to tan inverse 1 minus cos theta by sin theta. 1 minus cos theta can be written as 2 sin square theta by 2 with the help of a formula in trigonometrical transformation. So this is equal to tan inverse 2 sin square theta by 2, and here this sin theta can be written as 2 sin theta into cos theta. Here 2 will be cancelled out, this square will be cancelled out with sin theta. So we are getting here this is equal to tan inverse of tan theta by 2, and this is equal to theta by 2. Since tan inverse of tan x is equal to x, so we are getting here y is equal to half of theta, and from here we will get theta is equal to tan inverse x. So this is equal to tan inverse x. Now we can get the value of derivative of y with respect to x very easily. So therefore dy by dx is equal to half, and you know derivative of tan inverse x is 1 by 1 plus x square. So answer is 1 by 2 1 plus x square. This is the answer. So we have to see sometimes we need some proper substitution in trigonometrical form to reduce in a simpler form to get its derivative. Now let us see next question. If y is equal to tan inverse root over 1 plus x square minus root over 1 minus x square upon root over 1 plus x square plus root over 1 minus x square, find derivative of y with respect to x. Here we will put x is equal to x square is equal to cos of theta. So we will get y is equal to tan inverse root over 1 plus cos theta minus root over 1 minus cos theta upon root over 1 plus cos theta plus root over 1 minus cos theta, and this is equal to tan inverse 1 plus cos theta can be written as 2 cos theta by 2. So this is root over 2 cos 2 cos square theta by 2. Sorry. Minus, this can be written as 2 sin square theta by 2. Similarly, here we will write 2 cos square theta by 2 plus root over 2 sin square theta by 2. Then after taking root 2 common from each of these terms, root 2 will be cancelled out, and we are getting here tan inverse of square and square root sign will be cancelled out. So this is cos theta minus sin theta upon cos theta plus sin theta. Now dividing numerator and denominator by cos theta, so that it will be 1 and this will become tan theta. Similarly, it becomes 1 and this becomes tan theta. So this is equal to tan inverse 1 minus tan theta upon 1 plus tan theta. And try to recall the trigonometrical formula. This part can be written as tan of pi by 4 minus theta. So this is equal to tan inverse pi by 4 minus, tan inverse tan of pi by 4 minus theta. So tan inverse of tan x becomes x. So this is equal to pi by 4 minus theta. And theta can be written as from here pi by 4, theta is cos inverse x square. So this can be written as minus cos inverse x square. Now it has been reduced in a very simple form. Now we can get its differentiative in a very easy way. So we are getting here, we are getting y is equal to pi by 4 minus cos inverse x square, and therefore derivative of y with respect to x, this is constant, so its derivative will be 0, and minus 1 upon, you know the formula cos inverse x, that is minus 1 by root over 1 minus x square. So there will be a minus sign, minus 1 by root over 1 minus x square is already here, so this will be x to the power 4. And finally we are getting the answer, this is 1 by root over 1 minus x to the power 4. This is the answer. Now next question. If y is equal to sin inverse x root over 1 minus x minus root x into root over 1 minus x square. So in such problems we should have some practice for suitable substitutions. Here we will put x is equal to sin theta and root x is equal to sin of phi. So this y reduces as sin inverse. In place of x we are writing sin theta root over 1 minus, here root x is sin phi, so this x can be written as sin square phi, and minus root x, again this is sin phi and root over 1 minus sin square theta. After this substitution, this expression can be reduced in a very simple form of sine A minus B. Sine A into cos B minus cos A into sine B. So this is equal to sine inverse sine theta. This is cos of phi minus this is sine phi. This is cos theta. So minus cos theta into sine phi. So you see, it has been reduced in the form of sine A into cos B minus cos A into sine B, which is equal to, sine A minus B. So we are getting y is equal to sine of, this is sine inverse, and sine of theta minus phi. Sine inverse of sine x is simply x. So this is equal to theta minus phi. Now substituting the values of theta and phi from here, sine theta is x, so theta is sine inverse x. This is equal to sine inverse x, and minus sine phi is root x, so phi is sine inverse root x. Sine inverse root x. Now let us try to find out the derivative of y with respect to x. You know the formula? Derivative of sine inverse x is equal to 1 by root over 1 minus x square. And this is root x. So it can be differentiated with the help of chain rule. So this is equal to derivative of sine inverse root x with respect to root x and into derivative of root x with respect to x. So we are getting here dy by dx is equal to, this is 1 by root over 1 minus x square minus derivative of sine inverse of root x can be written as 1 by root over 1 minus its whole square is x, and derivative of root x is with respect to x is 1 by 2 root x. So we are getting answer here. Derivative of y with respect to x is 1 upon root over 1 minus x square minus 1 by 2 root x into root 1 minus x. This is the answer. Now let us see next question. This will be last question of this video. Question number 4. If y is equal to sine inverse 5x plus 12 root over 1 minus x square upon 13, then find derivative of y with respect to x. What will be substitution here? First, simplify it. Little bit we can simplify. This is equal to sine inverse. This is 5 by 13 into x plus 12 by 13 into root over 1 minus x square. So let us put here 5 by 13 is equal to sine alpha and x is equal to cos theta. So what will be value of cos alpha here? Root over 1 minus 5 square by 13 square. This is 12 by 13. So in place of 12 by 13 we can write cos alpha. So now this expression y can be written as sine inverse 5 by 13 is sine alpha, x is cos theta, plus 12 by 13 is cos alpha, and root over 1 minus x square means root over 1 minus cos square theta, that is sine theta. So you see, this is in the form of sine A into cos B plus cos A into sine B, which is equal to sine A plus B. So this is equal to sine inverse sine of alpha plus theta, and it reduces in the form of alpha plus theta. Value of alpha is here, sine inverse 5 by 13, sine inverse 5 by 13, and plus theta will be cos inverse alpha. This is, cos inverse x. Now we can get the derivative very easily. So derivative of y with respect to x, you see this is a constant number, there is no variable, so its derivative will be 0. And you know the formula, derivative of cos inverse x is minus 1 upon root over 1 minus x square. So finally we are getting the answer here, minus 1 by root over 1 minus x square. This is the answer. So dear students, these are the equations based on differentiation by trigonometrical transformations. However, I will suggest you to do some more practices to command over this topic, and I hope you might have got benefit from this video. So please transfer these videos, share these videos with your friends also, and please subscribe my channel so that you could get update in time every time. Thank you very much.